I wrote an application, and it sort of taken over my life. And it sort of started as a hobby, and I'll go through it. But just to begin, I'm going to give the thought of, what if you could give every user of your software the experience of having a dedicated server machine assigned to them? This is a different approach than you'll see in microservice and Kubernetes and all sorts of things. This is sort of what I've learned from my app. It may apply to other people. If it applies, cool. I worked at IBM for 39 years. Mentioned some highlights. You can go to Wikipedia and find out a whole bunch more. I'm not going to belabor any of that. I retired in June of 2020, middle of COVID. And I wrote an app March of 2022, which I'll be talking about. It's called Showcase. It's up on GitHub. And later that year, I unretired, joined Fly.io to host this app. And I've learned a hell of a lot of things. I'm sharing some of them with you. The app is for ballroom dancing. That was my hobby. That is my hobby. You might notice I've got gray in my beard. I've been around for a while. Well, the next step after gray beard is mobility issues, and I don't want to have that. So this was a nice social thing that kept me active and whatever. I do it with my wife, done that for like 12 years. And at the midst of COVID, the sort of the tail end of that, so we went to a dance competition, which dance competition is what this program does. I was scheduled to go on the floor with 2 different partners. It was a scheduling mishap. Basically, 6 or 8 or 12 couples go on the floor and they dance for a little bit, and judges judge them and do their thing, etc. Well, I had two entries, and that my wife went up to the guy who scheduled it and said, "What'd you do? You do this with a spreadsheet?" And he said, "Yes." And she said, "My husband can do better." And so I wrote a program. This shows 2 clone women. You just can't clone yourself and be on twice. So introduction, as you mentioned, Agile Web Development with Rails. The current version in beta is Agile Web Development with Rails 7.2, because Rails 7.2 just came out about a month or so ago. There's rumors that version 8 will ship in September, which seems kind of ambitious, but I'm prepared for that. These are the prior editions I've been involved with. There were 2 editions before this that I wasn't involved with, but the original author, Dave Thomas, asked me to pick it up on what was the 3rd edition, and I've been busy ever since. I work for Fly.io, which people have mentioned, and I wrote an app, started for Arthur Murray, and now a second group uses it. It's smooth.fly.dev. That's live. You can actually go to it, and there's demos you can run. The application is live, free field explore. Individual events that are run by individual studios, that data is private, and you got to log in to get to it, but you can run the demo, and the documentation and source code is available. All these 3 things are related. I wrote a book. It's a good way to get hired when the guy who's the CEO of the company learned Rails from your book. I used that Fly.io to host the application. The application is basically what I learned on Rails to applied, and it works both ways. Basically, the things by writing a real application, I've improved Fly.io and I've improved my book, and vice versa. My app is written in Ruby on Rails. It happens to be. Yours need not be. My host is Fly.io. Yours need not be. My scheduled ballroom dancing. The app is just for illustrative purposes. I'm about to go through my thought processes on how I evolved it to scale. And those apply to other platforms and whatever else. And I don't get paid on commission. You host wherever you feel comfortable. Defining the problem. In 2022, I wrote an app. 8 events were run in 6 cities in 1 country and 1 continent. In 2023, it went to 30 events in 2 continents and 3 countries. So far to date, I'm in 5 countries and 3 continents. It's 90 events. These are the United States. Mostly it was East Coast. It's starting to spread out. Second, I got a foothold in Australia, 3 different places. And I'm starting to do some in Europe. Interestingly, Warsaw, Poland, they had an event and they wanted to hold a second event. They did hold their second event in Kiev. and literally the next day, Russia bombed a children's hospital nearby or whatever else. So there are people using this trying to live their lives and whatever else in the midst of war. Talking about scaling, I mean exponential growth, tripling each year. It's still relatively small numbers, but it's growing. And users are geographically distributed. I mean, there's people in Sydney, Australia using it. Apps want to be near users, apps want to be near data. If you want to scale, you don't want to have lots of round trips around the world. Previous people talked about the speed of light and whatever. That actually is a big issue if you've got distributed data. So I'm going to talk about how I scaled my app to solve those last two problems. So the question is, what design choices can you make that could prepare me for 1,000 events? I mean, just if it keeps growing this way, it could be 2 to 3 years. Realistically, it's going to level off a little bit, whatever. But it may get to the point where I've got thousands of events. What engineering trade-offs? Nothing is free. You do this, it makes this better, and it makes that worse. And so what engineering trade-offs do you need to do to make this happen? Need a baseline to talk to. You may have heard of Kubernetes and microservice. They seem to be all arranged these days. I'm not a huge fan. Let's start with a chart from the top non-sponsored Google search for microservices. They literally have got a chart that looks like this, and we've seen previous presenters make fun of it. But let's look at something a little smaller. They talk about breaking your application into individual services, having different teams own individual services, and have them all deployed separately and whatever. On the same page where they describe this, they also describe an alternative that they describe as simpler. You put all your services together. Amusingly, they did Apache, which I've been involved with Apache. Tomcat, which is my first open source project at Apache. I was the first release manager outside of Sun. But they recommend this as a simple to deploy, test, develop, test, deploy, and scale. Those are good features. Those are what you would like to have. And this is on a microservices site saying, here's something that may be simpler. Simple's good. Microservices trades off complexity of orchestration for complexity in application complexity for orchestration complexity. Your application gets simpler, but it's a little harder to orchestrate. That may be a good trade-off for some. Both approaches can be made to scale, but neither approach directly addresses the key problems I mentioned. Apps want to be near users, apps want to be near data. Neither of them directly address that. Shared nothing is an architecture. You can Google it, it's been around for decades. My presentation is going to have multiple subparts. We'll start with a single user. I mean, I did go this way. I had a single user, then I went to multiple users, then I went to multiple machines. That's where you get to scalability. Macroservices, backups, logging, startups, and admin UI. I started with a single user, single VM. It was all on one machine. If you look at the way you develop, you put all your stuff on one machine. Databases, Redis, you name it. Some services may be in a container, but it's still in the same machine. You can do the same thing by putting all those same services in one Docker container and deploy it. Docker sort of doesn't recommend you do that, but it's actually a good way to go. And is the way I've gone. Rails application, Puma is the web server. Rails, I use SQLite. I've got a bunch of, people can upload songs that are actually played during the event. When I go solo, I have a particular song I've already pre-selected, and Redis is for coordinating WebSockets. This is a standard Rails type of deployment. My original deployment target was my Mac Mini in my attic. Ample capacity, these things can handle lots of stuff. Latency to Perth or Sydney or whatever would be a bit of an issue, but the biggest issue for me was inaccessible at times due to power outages and storms. Storms do come through the area. I live in Raleigh, which is not far from here. You get a storm, power goes out for a few hours. No big deal, you live through it, but if people are running their events off of your server and it's down, that's not a good thing. So I asked, Advantages of this, no need to modify your application. It just sort of runs the way you developed it. Eliminating the need for network and producing response to requests improves throughput and reliability. Anytime you put a network layer in between two things, like you got a Postgres database that's separate from it, that's another point of failure. First rule of distributed computing, don't. And ease of deployment, everything is there, you just deploy. Next step, running multiple users with separate databases. This step is technically optional. You could go to multiple machines immediately, but I actually put my second user on the same machine. It was on the Mac Mini. Making databases multi-tenant is hard, so I decided not to do that. All I needed was an application server that can serve multiple applications, and I chose Fusion Passenger, which is a way to get a single web server that routes off to different applications based on the URL. So my architecture now looks like this. Nginx, Fusion Passenger, I've got 2 Rails applications for 2 users. They have their own separate databases and data stores and whatever else. They actually share Redis, which I'll mention again in the next chart. Graybeards know this is a shared nothing architecture. Each individual piece shares nothing with any other piece. They all run completely independently. Amazon rediscovered this pattern and called it cell-based architecture, and I like that name too. You have got these individual cells that are sort of isolated. And as I mentioned, Redis is shared between the two, but only technically prefixes are used to make them independent. So all data is sort of isolated. A chart from Amazon, isolated failure with their cell-based architecture. A ship doesn't go down because one piece goes down. If I have a crash, I mean, if I've got a user that literally figures out a way to crash their application, it doesn't affect any other users. This is their picture for it, which is a cell router, application load balancer. Since it's Amazon, it's ECS and storage and whatever. I'm using different technologies, but this is their picture, and it's very similar to what I've done. Now we get to scalability, multiple machines. This is where I needed to go someplace else. I asked around, I had some friends, and they said, Fly.io looks cool. So I went to take a look at Fly.io and see if they could host my application. And they had this job posting for somebody, they needed somebody who knew Rails. Okay, I think I qualify. So I just mentioned it to them that, well, I mean, I'd like to learn about you, you'd like to learn from me, hey, let's get together. And next thing I know, a week later I was employed. That wasn't my plan, but it worked out that way. Anycast is a methodology where a single IP address is shared between multiple servers. Load balancing proxies such as Fly Proxy will route requests to an available server, and dynamic request routing, these are platform specific, can be used to route requests in the next place. So my architecture now looks like this. Anycast proxy to 3 different machines, each of which was what I was showing previously. Little individual things that have their own individual things. Layers upon layers upon layers. This is literally what I'm running today. Now, that chart is a little bit misleading. It looks like Anycast proxy is a bottleneck or a single machine or whatever else. Anycast is actually part of TCP/IP, the protocol. It's individual implementations of it. Individual proxies running on edge servers will be what's doing to it. So if a request comes from Sydney, it'll go to an edge server in Sydney, that'll go to our machine in Sydney, and never leave Sydney. The response will go back to the original. So someone in Sydney has no transports across the world. I'm in Raleigh, the nearest one is in Ashburn, Virginia. Here you might be to Atlanta. But it's all regional. Nothing ends up having to span continents or whatever else. Proxy sends it to the edge servers based on HTTP headers are provided, nearest available if not. The target machine can ask the request be routed or replayed. So I actually can access my Sydney server from Raleigh. It'll go to Ashburn as the closest hop, and it'll say, no, you don't want to be here, you want to go over there. So yes, I can get to Sydney. I won't have the same performance as someone who wants it locally, but it's nice for me to be able to debug this stuff. And it also is helpful if I'm on an airplane. I mean, basically, I could be in an airplane and access all my stuff. Everything is there available, but it's optimized for people near the event, which is sort of as you would hope it would be. These are where Fly has servers around the world. There's lots of cloud companies, and they all got pictures like this and show where their regions are. But I showed you 3 different places in Australia. They all use the Sydney server. I've got 9 servers in the United States, and at the moment only 1 in Europe, but as I need to expand, I will. I had shown an architecture where I could literally get to the point where each event was a separate machine. I don't actually go to one machine. Atlanta hosts a bunch of events. It's a bit of an eye chart, but you can actually see. One of the reasons why I still have multiple things on Atlanta is I'm still hosting the 2002 and 2023 just for reference. People can go back and look at old events. There's no reason to have a separate machine for those. Typically in Atlanta region, I've got 6 events this year. If you look closely, you might be able to see that 2 of them actually happen on the same day. So there is a little bit of overlap, but by and large, you won't have an awful lot of that. Reason why it's tolerable is by capacity planning. Each of those machines are tiny. 1 gigabyte of RAM is more than enough to handle all the events on a single server, even if you've got 2 or 3 users on the same place, and I've got multiple machines for different things. I've also got 2 gigabytes of swap, so if I ever go past the 1 gigabyte, I got plenty of room. CPU is next to nothing. The application's certainly not CPU constrained. Most requests takes less than 100 milliseconds to respond. And many requests are under 40 milliseconds. An average person generates a single-digit number of requests per minute. I mean, people are typing at a keyboard or clicking on mouse or whatever. So peak load is perhaps, 4 users or something on each individual machine. Response times are phenomenal. Basically, it responds faster than you can do. I mean, if I'm talking about 100 milliseconds, it's faster than you can perceive. And we're talking about local machines. So every data that request comes in, it doesn't have to go around the world. Everything's handled locally. Typically, a request never leaves a geographic region. Remote requests are still possible. I mentioned an airplane. Once a machine receives a request, everything needed to respond to that request is available on that machine. I don't have to go to a separate Postgres machine or a separate Redis server or whatever else. Both vertical, more events per machine and bigger machines are possible, and horizontal, more machine scaling is enabled by this architecture. Mission accomplished. Apps want to be near users, apps want to be near data. Now, if this was just an architecture presentation, you'd sort of say, I'm done. I mean, this is something I've really lived through and whatever else. There are individual reasons why you might want to deviate slightly from it. Revisiting microservices, I sort of made fun of the idea of splitting out invoicing from scheduling from data entry, but users want printed reports. It's not an uncommon requirement. Printing from the browser is a lousy end-user interface. If you ever try to print, you end up getting these headers across the top. Each browser is different and whatever else, and it's a big support nightmare. This is my app. This is me. It's not just, I don't have a team. So generating PDFs using Puppeteers is much better. Puppeteer is a nice little tool, typically around Node applications. So I've got a separate thing that uses PDFs from that. The problem, and the reason why this is different than the invoicing from scheduling from data, Puppeteer under the covers runs Chrome. You can pick a different browser, but pretty much everybody uses Chrome. Chrome is bigger than my app. Chrome is a memory hog. Running both events and Puppeteer on the same machine results in crashes. I mean, not often, but I mean, you can actually bring down the machine because of all this. So, solution, print on demand. Put that on a separate machine. My machines deal with Ruby on Rails. These machines deal with printing. They spin up and down as needed. If no one's printing, they're not up. We start machines in like 200 milliseconds, so that's not a big deal. If you're generating a PDF, an additional 200 milliseconds waiting while the thing spins up is okay. I provision them with 2 gigabytes of RAM and 2 gigabytes of swap each. At the moment, I got 4 geographically dispersed machines that are defined. Basically, everybody shares these machines. It's all transparent. You just basically go and say print. it'll reroute the request off to this machine, and it will end up spinning up if needed, do the print, and generating the response. So this is kind of like microservices. I'm calling it more macroservices, but splitting off things that, because of their resource requirements or constraints, based on just basically looking at different teams. Backups. Backing up 11 regions is a bigger problem than backing up one region. So I mean, yes, it's trade-offs. Having one Postgres database may make life easier, but I've got 11 sets of SQL databases, one SQL database per event. So I'm now up to, I don't remember the number, it's close to 200 events now. But one plus side is the data from the events don't overlap. The person who's working on this event we've got one running in Richmond today. Someone's running a competition today in Richmond. So they're doing some data entry in San Francisco at the moment, Salem, Oregon, and in Perth. Those data sets really don't overlap, so that's what makes this architecture good for my app. So what I've done is whenever an event goes idle, its databases and media files are copied to all other regions using rsync. It's a nice simple approach. Just once you stop pressing keystrokes, I want to get 5 minutes of idle. I just literally rsync all your databases, and I indiscriminately, because it's relatively small right now, I'm doing it to all regions so that if I ever want to, I can say, okay, I'm no longer running you out of Atlanta, I'm now going to redirect you to Chicago. And I can just change a pointer someplace, and the thing is just up and running because the data is already there. It also makes it easy for me to define a new event, etc. I also rsync everything back to my home server. That Mac Mini is still alive today, and it can run as a fallback of last resort. In other words, I could literally still run all the events from there. It'd be local for me, but it wouldn't be local for people in Perth, but it would still be, if everything went to hell, I'm still up and running. It also makes it easy for me to debug problems. Basically, someone calls me up and says, this doesn't work the way I want. I've already got the data on my server. I can actually run with live data, and I also take daily snapshots of everything using hard links when data is changed to minimize size. I've had lots of people say, oops, I actually redid my thing, but I already gone to print. That's not a good idea, because now the numbers of the heats don't match the numbers that I printed. Can we go back? Since I do daily snapshots, I can say, okay, I'll take it back to yesterday by just restoring the database. Thinking through backups is almost highly underrated, but it's one of the most important things in my mind. I mean, it saved my tail multiple times. When something's gone wrong, I could just basically go grab a copy and your backup will be running in seconds. Logging is a similar problem. The 11 region problem applies here too. You've got 11 sets of logs trying to keep track of everything. This is something that Flight.io ships things that helps you with. You'd have to find a different solution elsewhere. A log shipper application. I'll just provide some links if you want to go find out more about them. But basically, all the logs from all the different 11 regions are coalesced into one place, and you can actually send them off to. There's several different services that will end up helping you search and the like. Deploying an update is a matter of replacing a machine and starting the application. There's no ordering problems like you've got with if you've got microservices where you need to start this, and both of these depend on one another, but you need to deploy them in a certain order. Machines start in milliseconds, a small number of hundreds of milliseconds to be sure, but fast, and proxies will buffer. So while this machine's restarting, a request that comes in might have to wait 100 milliseconds till the machine comes up. There are cases where my application changes a database migration, or I need to rsync data from another place to get the database. So that might take a second or two or more. So the application start might be delayed, but those rare cases I show a please wait until it comes up. No big deal. And to me, the last piece of this is administration UI. Once you end up having this, it's nice to automate your own activities. I mean, I've got where I can add a user, I can add a region, I can add a studio, and this will under the covers run the fly control commands to actually let me create a new studio. Last night as I went back to the hotel, San Jose said we'll go on a second event, and I just a few mouse clicks away, and I created a new database and sent them off a link, and they were up and running. The ability to script your own sequences is highly underrated. I mean, really something I think is important. So this is what I said I'd go through. The part started with a single machine. I went to multiple users. I ran multiple machines, identified macro services. Again, this is where we scale and backups. Those are the two things I think are most important. Logging, startup, and admin UI. And I literally give every user the experience of their own server, run locally. Occasionally there's a second user that's there that they don't see, but it's all transparent to them. And again, it's highly resilient. If there's a rare case where someone figures out a way to clobber something, they don't affect anybody else. This entire presentation is online. If you go, I mean, I just posted it on LinkedIn, a link to the whole presentation. You can click the links. This last link is actually a more detailed version of everything I just showed here, with links to actual code showing how I implemented it. With that, any questions? Sure.
So you're running multiple copies of SQLite with Fly, and they're all syncing up to your home server?
Absolutely.
That's cool.
Sorry?
That's cool.
It's just using a tool called rsync, which has been around forever. rsync runs over SSH. So the way I've actually got that working is I don't have Fly SSHing into my server. I treat my server as if somebody broke into it, they've got access to the keys of the kingdom and all sorts of things, so I got the other way around. I have it called a webhook, which basically on my web server then says, okay, I'll SSH from Fly all the databases, and it just does an rsync of the SQL databases. I know at that moment that server is idle. So grabbing a copy of the files, which SQLite is just a file, grabbing a copy of the files when no one else is using it means I'm not going to get in the middle of a transaction and all the other stuff. I just grab a copy of the files. It's not brain surgery. And actually, again, the links at the last show actually the code that actually does it, and it's just a small little script that runs rsync. Yes?
Your admin site, is that a separate app that you're running?
No, it's actually just, it's literally the same app, but I actually run that one from my own home server. Basically, I could run it anywhere, but I have my home server be the one that is the orchestrator of the other stuff. I mean, I can actually literally bring it up, since we seem to have time. These are my various users. Last night I said I went into San Jose. Latitude and longitude, that's how it shows up on the map, basically. Events. I created their September event last night. If I wanted to create another event, it's just form fill and the like. This is running off my home server, which, as I said, is up in Raleigh. And when I'm done, I click apply, which I've got a series of things I scheduled. This has got no changes to apply at the moment, but if I created a new region or I created a new event or whatever else, this would literally run those commands one by one and show you the outputs as it goes. And at the moment, 46 cities, 128 events. I did mention, I mean, this is live. If you click on demo, you can actually go through and create a studio, create students, schedule heats, and all the stuff.
Is there ever a scenario where you have like a championship competition or multiple studio shared data? Like, is there ever a scenario where you'll have to share data?
At the moment, it's sort of the other way. Yes, yes to your question, but it's not the way you said it. Some events will have, events will typically have multiple studios come to them. And some people are sort of, they want to be the ones who are sort of control freaks and whatever else. They do all the data entry and they do all that stuff. The other ones are sort of more laissez-faire, which basically each of the individual studios have their own individual logins to my event, and they enter their own studios, students and the like, and it's all scheduled together. So right now, the studio in San Francisco is that way. They've actually got 6 different studios spread around the whole Bay Area, and they're all entering their own data. And they're all accessing it at the same time in that one event. Salem is using it that way, the Raleigh Studios does it that way, Virginia Beach does it that way. Most of the others seem to be more control freaks. I mean, as you can imagine, studio owners vary. But what's nice is it's a web application. One of the first questions they asked when they got this was, what do I need to install? Nothing. It runs in your browser. That is handy.
So, in order to take a backup, I think you mentioned that you take a backup of probably the databases, I guess, at home. What I'm trying to understand here is how do you ensure security from what you have at home with the remote server, either USSH or you get in some way, you use rsync, you mentioned.
I use rsync. I say basically only update if the date stamps are later. I'm only syncing data from machines that are idle, so I'm not actually in the middle of a transaction or the like. I've not had any problems. Basically, when someone does some data entry in Chicago, and after they're finished, there's a 5-minute break or whatever else, that data first goes to all my other regions within Fly. I like the idea where I could say, okay, I want to move this thing from here to here. I've noticed, for example, here you're probably closest to Atlanta. I live in Raleigh, and I'm actually closer to Virginia. Richmond is north of me, and you would think they would use Ashburn, Virginia, but their data packets seem to be going to Atlanta. Who knows how the cables run? Once I saw that, I said, okay, I'll just move you to Atlanta. And I just changed a thing in my web interface, and now all the requests are going to Atlanta. The databases were already there. So all I got to do is change a pointer and away it goes. But
so in terms of the setup that you have at home and these remote databases, is that like a VPN connection you have, or how?
I literally run OpenSSHD on Fly.io. And I've set it up so that my private keys are all at home, my public keys are up on OpenSSH there, and then I run a webhook from Fly back to my machine, which has got the private keys, to pull. Again, I'm assuming that if you break into Fly.io, which is probably damn hard, the worst you could do is break Fly.io. If you break into my home machine, I've got some other stuff there that I trust. I mean, I think this is highly secure. The stuff that's running, it's a reasonable for all the individuals doing studios and stuff. But if you got my keys to my GitHub account and you got my whatever, that might be a little bit more dicey.
All right, thank you.
Thank you very much, Sam.
Sure.
Give him a round of applause.